Hey guys, this is chapter 1, lesson 6, and the title of this is the converse of the Pythagorean theorem. Converse just means uh, basically the opposite of, or how could you use the Pythagorean theorem backwards. But before we even get to that, there's two parts to this lesson. Part of it is the converse of the Pythagorean theorem, part of it is what we're looking at right now. To be able to answer this question, if I gave you three measurements, could you tell me, yes, those measurements are the measurements of a triangle? Furthermore, could you tell me, are they the measurements of a right triangle? So there's two parts to this lesson. Those are the two questions we're going to answer. So let's get started. So for the first thing, how can you tell if three measurements are the measurements of a triangle? Well, not all measurements are the measurements of a triangle. You can kind of see in this little um, sketch right here. If I gave you the sides 3, 2, and 6, sounds good. I've got three numbers. A triangle has three sides. I guess it makes a triangle. But as you can see, the sides aren't going to connect with those measurements. That's not going to work. They're not going to form a triangle. These measurements, however, 5, 5, and 8, are a triangle. Now, you don't need to sit there and take a ruler and measure it out and see if it's going to form a triangle. There's a much easier way, and that is through what's called the triangle inequality theorem. And what that theorem says, I'm actually just going to get rid of this. It says that three measurements can be the measurement of a triangle when the sum of any two lengths of a triangle are greater than the third length. Now that sounds a bit wordy, but if we break it down, all it's saying is if I take, let's take the numbers 7, 15, and 6. If these three measurements are going to be the measurements of a triangle, then if I take any two of the measurements, so for instance 7 and 15, and find the sum of them, so I add them up, 7 plus 15, they need to be greater than the third length. So this statement, 7 plus 15 is greater than 6, needs to be true for all three of the combinations. So 7 plus 15, 7 plus 6 needs to be greater than 15, and that would be 15 and 6 need to be greater than 7. If these three statements are true, let me make that look a little better, then this is a triangle. Not a right triangle, it's just a triangle. 7 plus 15 is 22, and 22 is greater than 6, so this one checks out. 7 plus 6 is 13. 13 is not greater than 15. This one does not check out. And 15 plus 6 is 21. 21 is greater than 7. This one checks out. Because all three of these things did not check out, these are not the measurements of a triangle. It can't be true. These three measurements would form a shape like this, where the sides don't meet at one of the vertices, at one of the vertexes, and therefore it's not a triangle. Let's test out this triangle here, 5, 5, and 8. So 5 plus 5 needs to be greater than 8, which it is. 5 plus 5 is 10, and that's greater than 8. 5 plus 8 needs to be greater than 5, and that checks out because 5 plus 8 is 13, that's greater than 5. And then this 5 plus 8, the other side, needs to be greater than the other 5, which we already know it's true. And because all three of these statements are true, it forms a triangle, which we already have a drawing of it. Let's look at one more. This is actually a very easy concept. Is it possible to construct a triangle with the following side lengths? Let's use 6, 5, and 4. Is it possible for these three side lengths to be the side lengths of a triangle? Well, to test it out, I need to add them together and see if they're greater than the other side. So if you know how to add and tell if something's greater than or less than, you can find out if something is a triangle or not. Pretty easy. 6 plus 5 is 11. 11 is greater than 4, therefore that works. 6 plus 4 is 10, greater than 5, that works. 5 plus 4 is 9, which is greater than 6, that works. Because all three of these things work, the answer to the question is yes, they do form a triangle. And there's a triangle. And there's all that's to the triangle inequality theorem. So if you didn't already, I would pause the video, add a little of this to your notebook. And if you didn't quite follow what I was doing, maybe I went too fast for you, just rewind, rewatch. The other part of this lesson is how can I determine if three side lengths are the side lengths of a right triangle? So if you already know that they're going to form a triangle, how do you know will they be a right triangle? And you can use what we call the converse of the Pythagorean theorem. So all this really means is test the three side lengths in the Pythagorean theorem and see if it works out. So let's see. Say you have this triangle. We'll say it's 6, 7.5, and 4.5. Is this the lengths of a right triangle? Well, I know that the Pythagorean theorem states a squared plus b squared equals c squared. So if this is going to be true, this side would have to be the hypotenuse because it's the bigger of the three sides, and we know the biggest side in a right triangle is the hypotenuse. The other two would be the legs, so I'm going to just plug them in for A and B. Remember, it doesn't matter which one is which. And then I'm just going to solve. And all you're doing now is testing to make sure both sides of the equation are the same. So 4.5 squared is 20.25, 20 and 25 hundredths. 7.5 squared is 56.25, and obviously 6 times 6 is 36. So when I add this side of the equation together, 36 plus 20 and 25 hundredths, I get 56 and 25 hundredths, which is equal to the other side of the equation. And because this is true, then the answer to this question, is it a right triangle, is yes, these three sides form a right triangle. And that's really all that's to this lesson. If you can add, and maybe you need to use a calculator occasionally for squaring things, you can do this. You just need to understand it. So let's go through 1 or 2 word problems. The word problem applications are not that hard. All right, so here we have a land surveyor determines that a triangular plot of land. So I'm going to draw that right off the bat. We know that the land is triangular. And it has lines that are 400, 600, and 720 yards in length. So we'll label those in a sec. The 400-yard line runs east to west. So actually, I should redraw this triangle. Okay, east to west would be this way, and that's the 400-yard line. Okay. We want to know if determine whether either of the other two boundary lines runs north to south. Well, if one of the other lines is going to run north to south, that would be this direction. That would mean that they have to go like this would be this would be the plot of land. So the land is a triangle in shape. Really what this is asking us, it doesn't say it, but it wants to know, is this a right triangle? Because if we've got a straight line, and I know my lines aren't straight, but if we've got a straight line going from east to west, meeting a line that's going north to south, those two lines are perpendicular, and where they meet is going to form a right angle. And if that's the case, this would be a right triangle. So really, This question, without saying it, is asking, is this triangle a right triangle? And if it is, we don't know if it is, but if it is, the 600 has to go here, the 720 has to go here, because 720 would be the longest side, the hypotenuse, and these would be the legs. And if this is true, then the converse of the Pythagorean theorem would be true. Meaning if I took these values and plugged them into their appropriate spots in the Pythagorean theorem, it would work out. Now, I already know this math, but if you have a calculator and want to pause and try it yourself, you can. But 400 squared is going to be 160,000, and this is going to be 360,000 equals, and I'm going to work under this. This is 500, excuse me, 518, 200, okay? That should be 400, 518,400. So are these two things true? I don't think so, because when I add 160,000 plus 360,000, I get 520,000. And last time I checked, those two things are not equal. Because they are not equal, the answer to this question would be no. Okay, the other boundary lines can't run north to south because that would form a right angle, and that would be a right triangle. And these values, although they might be triangular, are not going to be a right triangle. So this is an example of how you could see this in a word problem. Let's look at a little bit easier of an application, just so you could see what another one looks like, because not all of them are going to be this difficult, but again, we've talked about this in class. Word problems aren't always going to say exactly what you're looking for. This didn't say anything about a right triangle, but I knew that east to west, north to south, those are going to be perpendicular, forming a right angle. And then we're talking about a right triangle, so then it told me, okay, Pythagorean theorem. So be careful, but let's look at a little simpler one right now. Same type of question, but a little easier. A triangular field, so right off the bat, we know it's a triangle, has boundary lines that are 40, 75, and 85 yards long. Determine whether these boundary lines form a right triangle, and explain. So 40, if they do form a right triangle, they are going to prove the Pythagorean theorem to be true. So 40 squared plus 75 squared, do those things added together equal 85 squared. I need to just do quick calculations. 85 squared is 7,225. Okay, 75 squared is 5,625, and 40 squared is 1,600. So if I add these two things together, I get 7,225, which is equal to itself. And because these two things are true, then yes is the answer to the question. Do they form a right triangle? Yes, they do. And why? If it asks you to explain, because the three values worked in the Pythagorean theorem. So that means the converse of the Pythagorean theorem is true. All right. And that's basically the lesson in a nutshell. So I know I went kind of fast through that. I figured it's easy enough that I could go a little bit faster, and if you needed to slow down, pause it, rewind, go back, make sense of it, and then I'd like everyone to try these 3 summary questions, show your work, bring them into class tomorrow, and then we'll go through them. The first one is 2 different questions. The second one is based on this triangle right here, and then the third one I'm going to need to scroll down so you can read the whole thing. It's a quick word problem. So try the 3 questions out. If you have questions, need answers, email me. Otherwise, I will see you tomorrow.